Hi, I'm Mark, and this is an activity that you could do in AP Physics 1, AP Physics 2, or AP Physics C. It's called Circuit Puzzles. This is puzzle number 1. I like to give this to students very early in the unit before they really know a lot about circuits. You see the schematic of the circuit here, and here's the circuit built with batteries and bulbs. So we've got a battery, bulb 1, bulb 2, and bulb 3. And the question is just predict the brightness when we close the switch. So I don't actually have a switch. I'm just going to connect this wire to the bulb base there. So go ahead, take a second, predict the brightness of the bulbs. Which one will be the brightest, if any? Which ones will be the same? So first I'll connect the circuit with the switch open, and then I'll connect bulb 3. So remember, this is 1, this is 2, and this is 3. So take a second, make your prediction. I'll connect the circuit. Notice the brightness of bulbs 1 and 2 approximately equal. Then I'll add bulb 3. Look at that. Isn't that cool? Bulb 1 got a lot brighter. Bulbs 2 and 3 got dimmer. They're close to equal. I think the difference is largely attributable to different brands of bulbs or just different bulb tolerances. So there's circuit puzzle 1. Your challenge is to explain what happened. So let's watch again. The circuit was first connected like this. Bulbs 1 and 2, their brightness approximately equal. Connect bulb 3, and look at that. They get really dim, bulbs 2 and 3, and they are approximately equal. I hope you can explain that. Next, we'll do circuit puzzle 2. Okay, so here's circuit puzzle 2. It's a little bit messy because there's a lot of wires, but this is the circuit. There's a battery, bulbs 1 and 2 side by side. The wires come together and they split again. 3 and 4 in a row, side by side with 5. I haven't connected anything yet, but your task is to predict the brightness of the 5 bulbs. I'm going to connect it and I'll show you what the brightness looks like, but first, make your prediction. I'll pause for a moment while you do that. Okay, now I'll connect the circuit. Notice, let's label the bulbs, why don't we, so it's clear. This is bulb 1, 2, having trouble making my 1s today. Bulb 1, 2, 3, 4, and then 5 over here, just like it looks in the schematic I drew. Here we go. Ha! There it is. Did you get it right? Look at that. Which one's the brightest? Bulb 5. Did any of you predict that bulb 5 was the brightest? Bulbs 1 and 2 are second brightest, and they're tied with each other, and 3 and 4 are third. Turn the lights off for a moment. That may make it show up better in the video. Erase these numbers for a moment because they're a little bit confusing. Bulbs 1 and 2 the brightest, or pardon me, bulb 5 the brightest, 1 and 2 second brightest and equal to each other, 3 and 4 third brightest, or the dimmest, and equal to each other. Next, I'll set up circuit puzzle 3. Okay, so here's puzzle number 3. Battery, bulb by itself, bulb number 2, bulbs 3 and 4 next to each other. Switch for 4 is open at first. Task is the same. Predict the brightness of the circuit before and after closing the switch. I'll pause for a minute while you make your prediction. Okay, so let's see what puzzle number 3 does. I'll connect the circuit and then I'll close the switch. Okay, so this is bulb 1. It's the brightest. This is bulb 2, and this is bulb 3. Notice that 2 and 3 look pretty much identical. 4 is not lit. I'll turn the lights out so we can see what happens a little better in the next part. Now I'll connect bulb 4. Look at that. That's pretty cool. Now, it's kind of hard to tell, but 1's the brightest, 2's the second brightest, 3 and 4 are very dim. 4, it doesn't look like it's on at all. But notice something is happening in 4. I'll unscrew it and look at 3. 2 and 3 both change. So something is definitely happening with 4. I hope your prediction was correct. You may have noticed that this circuit looks a lot like puzzle 1 with another bulb added side by side. Now I'll set up puzzle 4. Here's puzzle number 4. It has 5 bulbs, 1 and 2 in a row, side by side with them, or 3, 4, and 5. Notice there's no switch this time. So make your prediction. I will number my bulbs while I wait for you. Sorry it's so messy. There's no easy way to do this with these wires. Okay, I hope you've made your prediction. Now I'll connect the circuit and let's compare the brightness. Okay, 3 is the brightest, 1 and 2 are next brightest and the same as each other, and once again 4 and 5 are very dim. It looks like 5 is completely out, but maybe you can see it, I'm not sure. I can see that there's a little bit of a glow to it. Turn the lights out again. Once again, I'll prove to you that 5 is definitely doing something. When I unscrew it, 3 and 4 change. Notice 1 and 2 don't, but 3 and 4 change. Now, can you explain the brightness of these bulbs? I'll let you work on that while I set up the next puzzle. Okay, I've got circuit puzzle 5 set up. It's only got 2 bulbs, but it does have a capacitor. In order to make this work with bulbs, you really have to get one of these large capacitors that I got from Pasco Scientific. They're called Castle capacitors because they were developed for the Castle system of teaching about electricity. They're about $30 a piece, I think. They might be cheaper if you buy more at once. This is a 40th of a farad, so it's a pretty big capacitor, 25,000 microfarads, and it's bipolar. So you can hook it up either way and it still works. You won't ruin it. That's a really good feature when you're working with students. So I've got one of those already in the circuit. So what you're going to do again is you're going to predict the brightness of bulbs 1 and 2 when I connect the circuit. So I'll give you a moment to do that. If you're not familiar with a capacitor, this might be a surprise for you. By the way, teachers, this is an activity you might choose not to do with Physics 1 because capacitors are not a part of the Physics 1 curriculum for electricity. They're definitely a part of Physics 2 and Physics C. Okay, have you made your prediction? I'm ready if you are. There's bulb 1, There's bulb 2. Watch carefully. Did you see that? Now I'll disconnect the circuit. I'll turn the lights off so you can see what's happening again. So a capacitor stores electrical energy, and a way to discharge a capacitor is to just short it out across the top. It happens really quickly if you need to do that. So I just did that to make sure that the circuit works. So watch carefully again what happens when I connect the circuit. Did you see that? Bulb 1 gets very bright at first, and then it dims. Bulb 2 is out at first and gradually grows brighter until it's the same brightness as bulb 1. Watch again. There it is. Okay, so that's circuit puzzle 4. If you know a lot about capacitors, then you'll understand this readily. If not, this is going to be a bit of a mystery to you probably. But let's look at circuit puzzle, well, I'm sorry, that was circuit puzzle 5. I said 4. Let's look at circuit puzzle 6. Here's the last puzzle in this activity, puzzle number 6. So now we have a similar circuit to puzzle number 5, except I added a bulb. So I'll connect the circuit, and we'll watch, that'll be equivalent to the switch being closed. We'll watch the brightness of the bulbs. Your task is to predict how the brightness of the bulbs will change after I connect the circuit. So I'll pause for a moment while you make your prediction. I'll discharge my capacitor just to make sure it's not storing any energy. That should be enough. And now I'll connect the circuit and watch the bulbs carefully. That happened pretty quickly. So let's disconnect it, discharge the capacitor, and watch it a couple of more times. Get the energy out of the capacitor. Here we go. Disconnect it. I'll discharge it. This time I'll turn the lights out. That may make it easier to see. And let's watch again. One more time. I hope you're trying to explain this. So did you notice that bulb 2 starts out unlit and then gradually gets brighter till all 3 bulbs are equal in brightness? Notice that I can do this. I can discharge the capacitor, and we can see this over and over again. I didn't show you that before. Not sure I have a good connection there. Yeah, I don't have a good connection. Can't get it to discharge, but try again. We'll look at it one last time. So this is a great activity because you can do this with students at different levels. It doesn't require any mathematics. You can just talk to them about the idea of electricity as something that flows around in a circuit, and they can make their predictions just based on that. Oftentimes they'll get them right, and they tend to do better as they go along. It works in Physics 1, Physics 2, or Physics C. Although for Physics 1, you may want to leave the capacitor part out of it. I got this idea from a document that was on Alan Van Hubelen's website a long time ago. I think it may have been published in the Physics Teacher. Thanks for watching, and remember, what one fool can learn, another can.